So calculus, we are looking at the 5th day of curve sketching. Yesterday we looked at vertical asymptotes somewhat painfully, and we started a little look at horizontal asymptotes, and we will add to that oblique as well today. Let's look at the first example. F at x equals 3x plus 5 over 2x minus 1. So I use Desmos, but whatever it is that you want to use, we have a quick little look so that we can cheat for the first example. And we see a function that is doing that. Roughly. So we're going to look at our vertical asymptote. We know that that happens when our denominator is 0, so we know that there is one at x equals 1/2. I am looking at the limit as x approaches 1/2 from the right side and the limit as x approaches 1/2 from the left side. And it appears when I cheated that from the right side, let's get the direction straight, from the right side as I was getting closer and closer, it was approaching infinity. And from the left side, it looks like it's getting closer and closer to negative infinity. Let's just quick check with a value, see if that makes sense. So if I'm just a little past a half, what is my value? Just past 1/2. So there's 1/2. My value for the function is 326. So that's pretty darn big, relatively speaking. Let's look a little to the left of 1/2. Let's look at the function at 0.49. Give me a second here. So about negative 324. A large negative number, relatively speaking. So it appears that our vertical asymptote at 1/2 approaches infinity from the right and negative infinity from the left. Horizontally, as I was tracing along with my Desmos, it looked like it was approaching about 1.5 as we go further and further to the right and further to the left. Let's look at our method from yesterday. So if we are looking at the limit as x approaches infinity for 3x plus 5 over 2x minus 1, a great method is to factor out the largest power of the variable. I'm going to divide out an x plus 5 over x. I'm going to factor out an x on the bottom. I get 2. Sorry, that's an x. Negative 1 over x. And as I approach infinity, these fractions get closer and closer to 0. My x's actually divide out, and I am left with 3/2. So my horizontal asymptote is 3/2. When we are looking at asymptotes, vertical asymptotes, sorry, we are looking for zeros in the denominator. However, I just wanted to remind you from last semester that if we can divide evenly into the numerator, we don't in fact have an asymptote, we have a hole. So that when we divide that, we would get closer and closer as x approaches 2, we would get closer and closer to the value of 4. So what it would look like as x approaches 2, because that's the problem spot, divide out that common factor, it's going to get closer and closer to 4. Let's just check with a couple of values. What about 2.1? What about 1.9? Really, really close to that value of 2, which is where we potentially have a problem. I'm going to put 2.1 into the original function. and it is approximately 4.1. Put 1.9 into the original function, and it is 3.9. It is not approaching infinity or negative infinity for an asymptote. It confirms that we have a hole. So we would have at 2, gets closer and closer to 4, but undefined at that place. There. Just don't forget that helpful tool from last year. Okay, next example. Let's look at asymptotes for this one. First of all, vertical asymptotes. We are looking for those problem spots where my denominator is 0. This one factors nicely. It's always mine are so nice, and the ones I make you do are terrible. X plus 2, x minus 3. So we have problem spots at x equals negative 2 or x equals 3. Neither one of those divide evenly into the top, so we're talking about asymptotes, not holes. So we have problem spots at 1, 2, 3, and at negative 2. Let's look at a couple of values. Let's look really close to negative 2, but to the left of it. Oh, that'll do. And just to the right of it, let's see what's going on there. Okay, this is where the videos are you trusting me implicitly, which is just bonkers. So negative 12.4-ish. So as we approach from the left side, it appears to be approaching negative infinity. As we approach from the right side, about 11.6. Big relatively speaking, so we appear to be approaching positive infinity there. And I do the same thing to the left and to the right of 3, and it appears to be approaching negative infinity and positive infinity by putting in some values. Okay, so my graph is very roughly started. We're going to look at horizontal asymptotes. Okay. That is the limit as x approaches infinity, or negative infinity, for 3x divided by x squared subtract x subtract 6. So we are going to divide out the largest power of the variable, which would be an x squared on the bottom. 1 subtract x over x squared, subtract 6 over x squared. So I have 1 over x. An x will divide out, and I'm left with 3 over x, and 1 subtract some zeros because they will become negligible as x gets very, very large. As x gets very, very large, 3 divided by very, very large also gets really close to 0. The limit as x approaches negative infinity would be the same algebraic process, so we would end up at the same place just with 3 divided by negative infinity. We would still get closer and closer to 0. So as we go far to the right, we're going to get closer and closer to 0. As we get far to the left, we're going to get closer and closer to 0 from below because we're dividing by negative infinity. And we've got that funny thing in the middle there. So let's look at our function at 0. We will have 0 divided by negative 6. We end up at 0. We've got this funny place right here. We didn't look at critical points, but we assume there's going to be something going on at 0. Okay, this one's going to be fun. We're going to look at all of the asymptotes. We're looking for a vertical asymptote. for sake of ease, I'm going to try and factor the top, see if it's a whole or if it is in fact an asymptote. If it's a whole, x plus 1 would factor in, and then we'd have to have a 2x to get 2x squared. If you want a 1 and you want to get a negative 1, and if you did FOIL to check that, it would not work. So it is not factorable. I tried. That is not a whole. That is an asymptote, where x plus 1 is 0, x equals negative 1. Okay. There is a vertical asymptote where x equals negative 1. We're not sure what's going on to the left or to the right, but we've made a list. Now we're going to look at horizontal asymptotes. Let's get this sorted out. Okay, I'm going to look at the limit. As x approaches infinity of 2x squared plus 3x subtract 1, I am going to factor out the largest power of the variable. I have an x squared, so 2 plus 3 over x subtract 1 over x squared. If I factor out an x, I have 1 plus 1 over x. We know that all of these fraction guys would approach 0 as x gets bigger and bigger. This, however, I am left with x over 1 on the top, and as x gets really, really huge, this gets closer and closer to infinity. So there is no horizontal asymptote. Okay. However, there is an oblique asymptote. And what do I look for? Some of you could have answered that horizontal asymptote question in another way by looking at the degrees, but for an oblique asymptote, that will happen when the degree of the numerator is exactly one higher than that of the denominator. All right, let's figure this out. If we have an oblique asymptote, I need to figure out what it is. It's some sort of a line. I am going to use long division, denominator into numerator. Okay, here we go. X goes into 2x squared, 2x times. 2x times x is 2x squared. 2x times 1 is 2x. I hope you did long division in grade school. I subtract these two, I end up with x. Bring down the negative 1. X goes into x minus 1 one time. 1 times x is x. 1 times 1 is 1. I am going to subtract. Negative 1 subtract 1 is negative 2. So I can write this function as 2x plus 1 plus the remainder over the numerator. Sorry, the denominator. So that is the same as my original function, just written in a very ugly different way. So if I am looking for an asymptote, good form would be the limit as x approaches infinity for 2x plus 1 plus this This, just like we looked at before for horizontal asymptotes, gets closer and closer to 0. So same idea, as we get closer and closer to infinity, we will approach 2x plus 1. This will hold true whether you approach positive infinity or negative infinity, and this would be good form to show it. So our function has an asymptote at x equals -1, and it has an oblique asymptote at 2x plus 1, so a slope of 2. Come on, grade 9 math. Whoops, should be dotted, my bad. And I'm going to just look to the left and right of this -1 value. I'm going to look at the function at -1.1 and at negative decimal 9. I get 18.8 and -20.8. So it appears on either side of -1 that I am approaching negative infinity from the right and positive infinity from the left, and then approach my oblique asymptote as we approach infinity. Sorry, bad curve. Approach my oblique asymptote as I approach negative infinity as well.